这可能只是测试，
Hello. Hello. Okay, welcome everyone to the GOSIM Paris. Right now at this open platform here, we're going to present the GOSIM AI Spotlight finalists. So this is actually the first inaugural year for the GOSIM Spotlight program. The purpose of the program is to highlight innovative and new projects that deserve people to take a look at. This year we have 12 winners or 12 finalists for the AI portion of the Spotlight program. For this conference, all the projects are represented by booths. They all have booths representing their projects on the side of the halls here. Please visit them and learn more about the project details. Right now we're going to have 6 presentations this time, around 50 minutes each for them to pitch about their projects or tell people more about their projects. So I'm not going to give introductions on each one. I'll just introduce them as they come along. So first project we're going to talk about is Age, and the speaker is Cyril Monet. So hopefully I didn't pronounce it too badly. So please give your introduction. Thank you.
So hello everyone. I'm gonna present you Age, which is an open source platform that has been hosted by Eclipse Foundation. So in today's day and age, AI is becoming more and more advanced and more and more mature. And we think that with maturity of AI going up, there will be a need to go to edge deployment instead of what we're doing right now, which is more like a cloud-based development. So to do this, we need to have a solution that will allow us to easily switch from our neural network that has been trained with your favorite framework, for example, PyTorch or TensorFlow, into edge device. Doing this can be very hard, especially you have multiple challenges. The openness challenges. Indeed, right now, most of the SDK are proprietary, which means that if you developed your application for a specific hardware, then you will need to do it all again if you want to switch hardware. So this is going from reusable and adaptable tools. The independency is very important and very key, as you want to be free to choose the material and the component you want. And innovation, it's important to stay up to date, especially in the AI development. So yeah. This is why we propose H, which is a framework that allows you to load your model from your favorite framework, train it and optimize it. And once you have your optimized model, generate code in order to target specific hardware. To do this, our platform is available in GitLab, hosted by the foundation Eclipse. It's coded in C++ and Python, and it's available on most platform and packaged on PyPy. You can find it with a very lightweight modular core and a different plugin that you can use in order to keep a lightweight product. So I will talk about the Age in 3 different use cases: the import, the optimization, and the deployment of your neural network. For the import, we have a strong interoperability with ONNX, with more than 60 operators that are right now supported and many more to come, as well to support to generic operators if you want to create a custom operator. We support also most of the main embedded architecture. Once you've loaded your model, you can easily, with Age, assess the performance and the complexity of your model. For example, looking for bottleneck in computation or in a number of parameters, which then you can fine-tune your model using the optimization available in Age that we'll see later. And finally, the last point on import models, which is the modification of your graph. Age proposed a very novel model, graph matching model, that allow you to match part of your graph and to apply transformation onto it, allowing you to create dedicated transformation to target one specific hardware. For the optimization, as I said, you can target your model and then simplify it. Here's an example where we have a shuffle net layer, which is then dividing the memory by sex. We also support state-of-the-art quantization. So we support post-training quantization and quantization-aware training, which allow you to go to up to 4 bits. And then we also have tensor decomposition. So these compression methods are really at the state of the art, and right now we are having, for example, higher performances than M8, which is the Qualcomm framework. Then, if you want to deploy your model, we also support fully an integration with ONNX, which allow you to export your model to ONNX and then target the device you want. For example, using proprietary tools such as CubeAI, TensorRT, OpenVINO, and many more. The other aspect is the transparent deployment. This means that at each step of your optimization, you can see what has happened, and what is the state of your graph, what operation you're really doing into the graph. And this is done by creating source code in C, C++ instead of providing a binary, which means that you can review the code that has been generated by the platform. And of course, the platform is multi-target, which means that you're not stuck with one hardware. And completing on the openness of the framework, you have access to open schedule. For example, you can easily see the scheduling of your layers as well as the memory mapping of your application. This means that it's really easy to understand what is happening and how your model is running. So this project is supported by France 2030, and right now we have like 40 contributors and many industrial collaborators, and as well as academic partners, and many use cases. So one of the first use cases that we'll present is ArcelorMittal, which is using age to detect default in metal sheets that are going 20 meters per second. So they needed a very high-speed performance model detection. We also have EDF, which is the French energy. So that's use age for indoor localization with multiple sensors. So both visual sensor as well as an EMU, and the deployment on a STM32 hardware. Heat pump is also a project that showcased deployment on STM32, and the final project is NeuroCorgi, which is a project where we created an RTL generation in order to create specific hardware which map the neural network into it, which means that we have a specific hardware for the neural network, which brings very good performances in terms of latency and power consumption. So thank you very much for listening, and if you're interested, you can follow us on LinkedIn or join us on the Matrix chat. Thank you.
Thank you. Does anybody have any quick questions for Ciro? Okay. Thank you, Ciro. So next up, we'll continue on. The next up is Pavel from BLIC program. Yeah. Hello. So I'll let him do all the talking. So give you the time to. Thank you, Pavel.
Thank you very much. I will stand here, maybe. Hello and welcome. I would like to tell you a bit about the rise of BLIC AI, which is Polish community-powered AI. And before we start, do any one of you know what this number means? It's a volumetric amount of Polish data in Llama 2 training set. It's quite small number, given that Polish language is maybe not the hardest in the world, but it's also the easiest, but it's for sure one of the hardest ones in Europe. It's hard to encapsulate the history, all the conjugations of nouns, verbs, all the idioms, and given the Europe itself, we have about 200 languages, including dialects. So that's why in November 2022, we started our initiative, and we started Spiegler Foundation with our mission solely being focused on data, on promotion of Polish AI. We wanted to hop on the train of AI being an industrial revolution, and also we wanted to democratize AI so it can be available for each and everyone in their own house. So our road to 1 terabyte of textual data started. In March we had over 100 gigs of data. In September we had almost 400 gigs. And in December we reached 833 gigs. So in a year we gathered over 800 gigs of data. That's then when we decided to train our first model. It was 1B model. It is toy model today. And this was the beginning that was needed. But it wasn't the best one. It could generate, so I give you 10 seconds to dig into this output. It's hilarious when we look at it. So we knew that we can create a model that does something, gives some outputs, but not the quality output we wanted to get. That's why in February, so not long ago, we decided to launch some benchmarks. So we knew we could create models, then we have to get some tools to evaluate those on the quality we wanted them to be. And the cycle started. So we trained, tested, repeated. Trained, tested, repeated. So on, so on. Since we got noticed, it was December 2023 when we started cooperation with the Polish Supercomputer Center in Krakow. They were currently building the biggest and the most powerful up-to-date Polish supercomputer called Helios, which is ranked 55th on the top 500 list, and third most energy-efficient supercomputer in the world, which is a very great achievement of theirs. They're world-class specialists, and we're here due to their work also. So in the meantime, in January 2024, we gathered our 1 terabyte of data. So this was a big milestone, and then we kind of achieved our dream. So in April, we released a first model of ours, 7B Bielik V1. It was good, not the best, but the real contender came in August 2024. So Bielik version 2nd. It was trained on the Polish text corpora. It was first community-based model in Poland. It was the first model to embrace full SFT and DPO pipeline. It was available in various formats, and most important, it was created without any financing. We did it after our daily jobs, after our office jobs. We did it at night, basically. And that's the family picture of version 1, 2, and 3, which I didn't mention, since today we'll be releasing 2 models, about which we will tell in a moment. So the features that V3 will have are the Polish tokenizer, dedicated one, function calling and reasoning, and yeah, those will be 1.5, 4.5b, 11b, and maybe something more. Follow us to know a bit more. So why are we, as a foundation, as a movement, quite unique? Since our data is AI Act ready, we got all the manifests, all the sources, all the data. We have our dedicated analytics dashboard with 120 categories of data, with our dedicated quality metrics. We have our own dedicated training pipeline based on our Alamo framework, which is being created by one of our colleagues. It's pure PyTorch. It works with weights and biases. It supports basically any training you want, including SFT, DPO, DPOP, adaptive LR, name it, we probably have it. And also, regarding quality, we develop not only models, but also tools and benchmarks to qualify those and to check whether they are good or not. We also focus on the Polish language and nuances to encapsulate the cultural and cultural context as good as we can. So, about the whole data set. We are the current Polish biggest Polish corpus of dataset with almost 3 terabytes of data, which corresponds to about 1 T of tokens in LLM world. Then about Bielik AI, so our language LLM-oriented initiative, we have almost 500,000 of models downloaded on Hugging Face. We have over 3,000 community members on our Discord channel, and we got over 1 million answers on our online chat, which you can reach at chatbielik.ai. So regarding benchmarks, we create those, and we have dozens of those, but I will show you only the most interesting ones. First one was Polish large language model leaderboard, in which the current champion is Llama, but Bielik with 11 B parameters is in top 10, as you can see, and it's only being outranked by way bigger and models created with way more cash than we did, since we got none. So then next one, it's Empty Bench. I believe you know this one, but we didn't also only translate it, we also localize it. So we don't ask about Cincinnati or vacation in Hawaii or how to make a burger. We ask about wakacje in Ciechocinek or how to make Polish kluski śląskie, because we want to also encapsulate and answer the questions about the Polish cultural language. And here's the very interesting comparison. In green we have our first model, so V1. In red we have Llama 405, and in blue we have Bielik V2. So as you can see, it gives Llama a run for its money in some categories. Also, to even embrace the cultural context a bit more, we created complex Polish text understanding leaderboard, in which we try to answer the questions whether the model can understand the phraseology and the specifics of given language. Also, Bielik is ranked quite high here, only outranked by the way bigger models. We also have our chat arena, in which you can put up a prompt, models are being randomly chosen, you rate them, and based on this we have the ELO rank. As you can see, Bieliks are swarming the place. What's more, we also wanted to try out how the model that's being trained on Polish and English can perform in different languages. So here's the scanned eval benchmark. So model hasn't seen any Scandinavian languages, but it still ranks top 10 in the Scandinavian benchmark. The same goes to the Czech benchmark. So our friendly neighborhood Czech Republic have also their own benchmark. And here's how the Bielik performs in this one. Still no budget. So after the premiere, we had our first business deployments. So startups, mobile apps, you name it, we have it. And one of friends of ours, so Gaius Lex, shared some benchmark data with us, their internal benchmark. In them, you can see how Bielik compares to GPT-4 and Mixtral 8x7. Given the amounts of data and funding those models have, I believe we again make them run for their money. We have also first products based on the Bielik, so this Matena analyzer, where Bielik gets the output from the visual model and then structures it and makes it more polished in Polish, so it can be way better digested by the Polish customer. Then there are way bigger players, so we have Snowflake, we have IBPM, we have IBM's Watson X, Bielik is also there, and a lot of other deployments. So Polish banks like PKO, like French Crédit Agricole, the biggest Polish social insurance company ZUS also uses Bielik, and also some local institutions like local Wrocław Town Hall unit uses Bielik too. But the deployment we are most happy about is the one we didn't know about. So Proste Pismo, or Easy Writing in English, is an app created by Poznań scientists. It's based on Bielik, and it's used by the team of Polish Presidency of Council in the European Union. We didn't know about it until it was released. So that embraces the very nature of open source. They just downloaded the model, created a solution around it. They just, hey, we have it, it works, and we use it as a Polish presidency tool in the European Union. Sorry for that. So is it a champagne time? Some deployments, some successes? No, not yet. It's not done. So anyone of you knows what it is? I don't ask Polish natives. So we asked some bigger models what it is. So they say it's some Indian dish, some Russian, some Czech one, and the Czech one is the closest in my opinion. But this one is Polish dish called gumikleizy or kluski śląskie. So these are kind of dumplings, basically. So our work is not done. That's why we launched a Citizen Bielik initiative. We want to have a citizen-generated data in which each and every one of you can collect, describe, annotate everything that can be seen. So photos, scans, images, everywhere. Everything. We want to engage every group. We will have a mobile app which you can use, and whether you go over something interesting in the city, you just make a picture, annotate it, and it will be done and included in our project. Also, we're creating a model guard, so it will be called Suika, so we stay in bird naming scheme. We have our own taxonomy, and we also released the first data set we created for people to annotate, and in a short time we got over 60,000 answers from our community, basically. Also, another big cooperation of ours is National Digital Archives, which have about 2 petabytes of data, and we agreed on processing this and making it happen to help them classify this data and make it even better and even better describe for their future purposes. So, and a small glimpse of what we'll be releasing tonight, so our models that will be released in the evening, I believe I can say this, they will be able to do the reasoning, so trend of lately, and they will be also supporting function calling, which example of this you have here. And the roadmap for this year. So we are currently in Q2, so we'll be releasing today 1.5 and 4.5b. We are working on guardrails, on citizen data sets. In Q3, we want Bielik v3 in bigger weight class, so 11b and maybe some more. Then we will have Q4 ended up with Bielik multimodal, so the output of the citizen dataset project we are currently handling. Thank you for your attention. If you want to catch up, here's the data.
Thank you, Pavel. Does anyone have any questions? We have 1 minute, but we're hooking up the next machine, so if anybody has questions, please feel free to ask. We're actually ahead of schedule, so that's great. Oh, there's a question.
Hello. It's Relive. Yeah, very nice presentation. We love this. Yeah. You can hear me? Yes. Ah, okay. Sorry. I'm not used to microphones. Very great presentation. Thank you for that. You know, I'm biased. I'm half Polish, so I'm glad to see this. I guess if you want to play with it, because I'm not an expert in that, can we access it to an API, or like what's the, like if I want to play with this tomorrow, what do I have to do?
So all the models we released are available on Hugging Face, so you can just go and download it. We have chat.bielik.ai, where we have like GPT-like experience, so you can go there and use it for free. But all our work is available as an open source, since we are here. So you can go on our GitHub, on our Discord, on our Hugging Face, and just get the data, get the models, and just play with those. So the models we'll be releasing today will be also available on Hugging Face in the evening.
Great. Thank you very much. Again, a reminder, all the projects have booths, so they'll have a booth table on this side, so please feel free to visit them and ask more questions. Thank you. Okay, let's move on to the next speaker. Next speaker, we have Hong-In Taif from GOSIM Edge, Llama Edge. So without further ado, I'll let you take over. Thank you.
Okay, hello everyone. I'm Hong-In Tai, and today I'm going to talk about how to run an Gen AI models on your edge devices with Llama Edge. Not only the edge devices, you can run with your MacBook, with your PC with your like a Jackson Nano or any small devices, just image it. We are very lightweight runtime to run any AI models. So actually, we are not. Oh, okay. So we are not only support a single runtime. Actually, we have support all of this runtime. Even you have the GGUF model, you want to use the Lambda CPP, or you have the OpenVINO or TensorFlow or other like the text to sound or text to voice, like the ChatTDS or Piper, or you have the voice to text model like the Whisper, and all of them we are all supported. So if you want to use the Mac, we support the MLX. If you're using CUDA, of course the PyTorch, the TensorFlow Lite, and Lambda CPP, we are all supported. And if you provide, if you are a runtime provider, you want to join in this list, just to contact us. We are very happy to support your runtime as our new backend. Also, we are supporting multiple hardware because that we want to to remove the boundary of each users to use your applications and AI models. So basically, if you are the the AMD 64 or your ARM 64 platform, we are all supported, and we are still working on the RISC-V and other architecture like the S 1390 platform provided by IBM, and lots of different CPU we are still working on. And also, there are lots of different GPU support are already on the list. For example, you can use the Apple Silicon, you can use CUDA, you can use Vulkan, you can use OpenBlast, lots of different frameworks to use your AMD or your NVIDIA GPUs. Also, if you have some very special machines like the NVIDIA Jackson Nano or the Ori Ajax or the new Project Digitals, we are all so supported. So you don't need to worry about that. You have to teach your users, hey, you must buy some kind of the hardware and you must install the specific runtime to run your application and AI models. Llama Edge will take care of all of it, because we will try to match your hardware and install the corresponding runtime platforms for you, so you don't need to worry about the dependency. So basically, you provide lots of different kinds of formats, and then the Llama Edge will try to integrate lots of different hardware platforms, lots of different frameworks, and all you need to do is to ship your model, ship your application to your users, and Llama Edge will take care of that, and then just dispatch your models to the correct runtime to use it. And you will say, I have an application and I compile for a specific operating system or specific platforms, like I'm using the Intel CPU with Windows, or I'm using the MacBook. How you handle it? The answer is that we provide all of this abstraction layer by the Watson Edge runtime. Is basically just a WebAssembly runtime, and it supports almost all of the platform you use, even on Android or on iOS. Okay, so basically, because we run the applications on the Watson Edge runtime, so you don't need to worry about how to handle the operating system part or how to handle the hardware part. We will just abstract all of these things. And we are not only create the service for the application and for the just the LLM provider or model provider. We actually integrate some different MCP, so you can build your own AI agent. For example, you can just check the weather. I will demo it later, or you can check the database information, or you can check everything you need via the MCP server and MCP client. So let's go into the demo. Let me check. Okay. So basically, I use a special framework called GaiaNet to set up all of this thing, but you don't need to worry about that because once you set up, you will create you will create a website like this, so you can just chat your answers, check your questions with it. So for example, we just create a new chat. And before we start it, you can find that this is the NCP server. It will go to the openweathermaps.org, and you will look up the weathers for me. So let me ask, what's the weather in Paris, and what should I wear today? So let me check. Oh, great, it's back. Because, I actually prepared a video for it because the network issue, right? It may failed. Just a couple minutes ago, I failed several times. But yeah, I'm very lucky today. So, you can check the weather here, and it should be correct. So let's check the website. Yeah, I think it's just correct. And of course, you can have different NCP services just to build it. And if you want to try it, here we go. So if you want to try it, we have set up simple installer, so you can just install the whole stack, and we choose the model is the Q13, and of course if you want to use the Lava 4 or any other models, is totally fine. But just make sure that your model supports the tool coding. Okay, you cannot choose a model that doesn't support the tool coding, so it cannot interact with your NCP server. So when you install it, and you will need to run a command called the Gaia init, and basically you will download lots of different NCP server we already provided, such as weather calculator, or you can do the search or the Quadron NCP server. So lots of different NCP server here, and of course you can just install your own one. For example, you build your other NCP server and just put it here. And then don't forget to enable it to edit this config and to start your NCP server. And just make sure that if you want trying to use the openweather map, you have to set up your API key. Yep. So once you set up, and you can start the whole framework, and basically you will create the Quadron database for your RAG application, and you will start lots of different NCP clients to connect each service you provide. And also the most important part is the LLM engine. For example, we use llama.cpp for all GGUF models, and very simple check UI. Of course, this provide the API endpoint, so you can do such as this thing. You can just call it with the the API endpoint, just like the OpenAI computable service. So you just put it, and I just look up the weather in Taipei, and yeah, it just going back here. So basically, you can have all this set up with our all-in-one start kit. So here is my last slide. You can check all of this project, and if you want to see the slide, this is a QR code, and yeah, that's all of it. Thank you so much.
Thank you, Hong-Ying. Does anybody have any questions for Hong-Ying? Question up here?
Thank you very much for the presentation. You talked a little bit about mobile phone compatibility. How easy is it to use on mobile phones? Llama Edge, I mean.
Yeah, so basically because we use the WhatsApp runtime and it's just binary, so you can install that application on your mobile phone. And then your application is called the Llama Edge, right? You just put your application on this runtime and everything is done. But because there are some limitations, something like the iOS, they don't want you to have a compiler or the JIT inside, so the performance may be downgraded because that you only have the interpreter mode of it. But you can still install all of this stack on your mobile phone, like Android or iPhone. Yeah. Yeah.
Okay, thank you. Again, he'll be at the booth over here by Llama Edge. So if you have questions, please stop by and ask him more. Thank you. All right. Next up, we have Tian Yu. So he's going to talk about his actually AI paper. So he'll talk about it more. Tian Yu?
Hello, I'm Tian Yu Chen from Peking University and also Microsoft Research Asia. Oh, thank you. Okay. And my topic is about automatic proof generation for Rust code via self-evolution, and this is our Eclair 25 paper. And it consists of 4 parts. First, the motivation and background of formal verification, especially in Rust, and our safe approach and some evaluation results and some future work. First, I will introduce the background of verification. And now that the bugs in software are very costly, especially in some critical domains. For example, the operating system in a rocket or in an airplane. And additionally, nowadays people tend to use AI tools during their development, and more than 60% of developers use AI tools during their daily work. However, even the large number of developers use AI tools, they cannot trust the code generated by AI models. Also, more than 60% of developers think that they can't trust the code, so they have to check the code themselves. And so we propose to integrate formal verification with large language models to generate trustable code. For example, nowadays people use large language models to translate their intention into generated code. And then we can use formal verification as the feedback of the code generated by large language models. Specifically, we first use the large language models to generate a formal spec, which correspond to their intention. And then we also use the model to generate proofs, and we use a theorem prover to check whether the generated code satisfies to the spec, or it gives a feedback, and to ask the large language models to regenerate the code or the proof. And first, we provide some background knowledge about software formal verification. For example, this is a simple program with only assignment statement. And the verifier will change it into a logic formula. Then it invokes the SMT solver to reduce the formula. And we see that this reduced formula is a tautology, so it will always be true. Thus, we can finish the verification process that this program will always satisfy the assertion statement. And our vision is to train an AI model to write verifiably correct Rust code. And our target is to automatically generate Veras code. And Veras is an extended language based on Rust. And we use it to generate specifications, which include precondition and postcondition as highlighted in red and in green. And also we use it to generate proofs. For example, some loop invariants highlighted in gray, or other assertions or lemmas. And the input is a pure Rust program, and the output is the verifiable Rust program. And the reason we choose Veras is that this this formal language has received increasing attention. For example, it is proposed in USA 23 and receives Source 24 distinguished artifact. And also, there are many work focused on automated various generation. For example, auto-various use prompt engineering, and our safe work, we use self-evolution, and further work, alpha various use tree search to improve the search efficiency. And this task requires several capabilities of large language models. For example, a need to understanding and the generation ability on formal verification, and needs to understand the user intention into a formal format, and a need to generate specifications and proofs. And also, the large language models cannot directly generate the verified code, so it might include the neural symbolic interaction, that is the self-debugging step. For example, I need to understand the feedback of a serial prover and locating and fixing the error based on the prover's feedback. And the key challenge is insufficient data for code verification. There are limited code verification knowledge in general pre-training models. For example, GPT-4o can only verify less than 2% of single function Rust programs. Also, there are very limited Rust code dataset. For example, less than 10 projects, less than 100,000 lines of code, and less than 500,000 of tokens. So it is impossible for a human to write enough code for training. For example, an expert can only write 500 to 1,000 lines per month, and there are about only 20 experts in the world. So our hope is to automatically to synthesize sufficient various data to train a large language model. And first, we'll briefly introduce our preceding work, auto-various. It consists of 3 steps: preliminary proof generation, generic proof refinement, and an error-driven self-debugging procedure. First, during the proof generation step, it writes a sophisticated prompt with about 1,000 lines to tell the large language models what is a various code and what is a various proof. Then it consists of 5 agents focused on 5 specific errors. For example, constant propagation, or array length checking, or quantifier checking, or conditional looping invariant checking. And finally, it uses a debugging procedure with a Houdini algorithm to debug the looping invariants generated by, for example, GPT-4o. And in our work, our key insight is to couple data synthesis and model fine-tuning via self-evolving. Thus, it can leverage the definitive power of a symbolic verifier in telling the correct proof from incorrect ones. And that is, various prover might not have false positive. And in each step, in the first step, we use a various compiler to filter out various compatible programs. Then, during the specification generation step, we use test cases to filter out incomplete and unsound specifications. And in the proof generation step, we use the various prover to filter verified various programs. And this is our safe framework. You see that it consists of 3 parts: various compatible code generation, and a self-evolving spec synthesis, and a self-evolving proof synthesis. And during the spec generation, the input is the user intention. It is always written in natural language. And the output is a formal specification, including preconditions and postconditions. And when filtering specifications, we use test cases with 2 criteria. First is soundness. That it means the specification must be compatible with the test cases. And second is completeness. That means the complete specification must point out that the incorrect test cases, here we just mutate the output of a test case to become an incorrect one. And for example, this specification is not complete enough, so we discard it. And during proof generation, in the first step, we use our preceding work, AutoVarious, with several sophisticated prompts. And here we provide some key results. For example, our save work achieved more than 100 times faster in data generation. For example, when using GPT-4, it costs 30 days, almost 1 month, to generate 3,000 verified programs. Well, with our self-evolving framework, we use 8H100 GPU can generate more than 19,000 of verified programs within only 1 day. And as for the effectiveness, we achieve 4 times more accuracy than GPT-4, even using a small Llama 3 with 8 billion of parameters. And the improvement of self-debugging, we show that 1 round of self-debugging is sufficient, and the decoding strategy of sampling and greedy might outperform than greedy than sampling. And here's the conclusion that we propose saves a novel self-evolving framework to advance automated proof generation for Rust code. And here is a demo. Here's a demo. We show that our model is integrated with a VS Code extension. And for example, it is a human-written code that includes a docstring, which shows the user intention, while the code implementation is, well, the code is not implemented. There is a to-do comment. And first, we use our various Copilot extension to generate specifications. For example, we will show that it invokes the backend model. And, sorry. First, it invokes the backend model to generate specifications. And we show that the various specification is generated here, and then we use a Copilot to generate the code implementation for this binary search function. We show that the Copilot generated one implementation for this binary search function. Then we also use the various Copilot to generate proofs for this specification and the code implementation. This might take a bit long time, as it might invoke the backend model several times if it cannot generate a satisfied proof. We see that it tries to invoke the large language models, and while there does not exist a satisfied proof. From this error message, we show that the key point to this code implementation is that there exists a arithmetic overflow error. For example, here it directly adds a low and high. Well, it might include an arithmetic overflow error. So we also use Copilot to change it to a correct implementation. And then we can use the backend model to generate the proof code. And we see that there are 2 verified and no errors. So this code implementation satisfies the given user intention. And here's some future work. For example, we are currently focusing on adding proofs and specifications for more difficult coding problems. Here is an example of coding problems that it is written as an optimization problem. We might neglect the details of it. And the ground truth specification is written following the format in the blue code. For example, there exists a combination of each coins that it is a valid combination, and for all valid combination as end-to-end happiness is less than or equals the output of this task. And also there exists a valid combination that can achieve the happiness. Well, you see that, however, the problem can be very easy to written with only one line. And existing models might directly output the solution or at just output a trivial solution. For example, result as greater than or equal 0. And our main solution is to fine-tune our reasoning model, as the reasoning model can divide the user intention step by step and output the target specification and also output the target proof. And this is my talk. Thank you.
Thank you, Tianyu. So let's have time for one question. Does anybody have any questions for Tianyu?
Hello. Are you facing problems with the stopping of the algebras? Because you know that sometimes the proof can enter into not finishing due to the Gödel theorem. That the algebras enter in a not, you cannot evaluate it or demonstrate it properly. Have you faced the problem that they could not stop entering a demonstration?
It has a time budget with maybe certain attempts of large language models invocation. If it still not output the satisfied proof, it will output the error message to the user, and user might check whether it is due to the code implementation or it is due to the proof, or the proof is insufficient. And in this way, it needs to invoke human in the loop to resolve this issue.
Thank you, Tianyu. Thank you. Okay, again, his table is, I think, also on this side, so please visit him and ask more questions. And next up, we're gonna have a Gautier. He's gonna talk about his project called Poly. There you go. Thank you.
Thank you, and hi everyone. So what I'm going to talk about today is Poly. So the Poly is a model and a method to perform. Oh yes, thank you. To perform efficient document retrieval with vision language models. So this is a project between the company I'm the head of research and development of, so Ilwin Technology, and an academic lab at Centrale Supélec, a French engineering school. The project, the lead author on the project was Manuel Feis, but was not available today, so I'm here. The underlying problem is the following. We know that RAG is the #1 business use case for generative AI currently, to us at least. It's a very powerful method, but a challenging one. So I don't know if you know the main pipeline behind that, but we have a set of documents, and we are going to store them into a database with the chunks and vectors. And we have a query that is asked, and we retrieve the top K relevant chunks that we feed to an LLM, and we get an answer. So that's the standard pipeline for RAG. But it's a very challenging one for many reasons. The first one is that in a standard RAG pipeline, we use several models. So we can use OCR models, layout detection models, table figure detection, etc. A lot of models. And then we can even possibly caption figures. We can chunk the different paragraphs, etc. So that's a lot of operations. And we actually are making a lot of mistakes that build up on each other. And these pipelines are very complex and slow. So what we propose is that to use vision language models to adopt a new strategy for RAG. So a vision language model, it's very simply a model that takes as inputs a text, like a query, so like what kind of dog is it, and an image, so the image of a dog, and the vision language model is going to give a reply, an answer. So it's a Labrador. What we are going to do is that we can use these models for various tasks like captioning, natural image, parse the results of documents, or even use vision question answering on complex figures. So, what does it look like, standard VLM architecture? So we have a vision model. So here it's a SIGLIP model that takes an image, encodes it, and then there's a linear projection that encodes the image into the same space as the tokens of the language model. So we have the vision model on one part and the query on the other part that are both fed to language model. So here it's GEMA, because it's the PaLi-GEMA architecture that was the first one that we use for the Core-PaLi model. So it looks like that. And what we propose is to rethink the strategy for the RAG pipeline. So instead of having a standard pipeline that work on extracted textual content, we're going to train retrievers that work and using the document image. So now we are comparing a query not to chunks of text, but to images of documents. So that's the new approach. And it's it's more performance, it's faster, and it's a trainable approach. So these are many advantages. What we've done is that we first designed a benchmark. So it's called the VDORE benchmark in order to assess the relevance of such an approach. So we've used academic data sets that you can see on the top of the table, and also industrial documents that are more relevant to our specific applications. So in different domains like energy, government, healthcare, AI, and environment. So this data set is really to assess the relevance of the approach. What does it look like? It's the image of a page, and associated to it, there's a query, like for this page, what types of accounts or products allow investors to defer paying taxes? So we have, I don't know the exact number, but several hundred types of such queries. So I'll go a little bit further. So what does it look like, the Core-PaLi approach, in terms of pipeline? Before, at the top of this slide, you have the standard retrieval approach, and at the bottom, Core-PaLi ours. So now we are going to take the image of the document. We're going to divide it into patches for the image. We're going to use the VLM and feed these patches to this VLM. And we're going to have several embeddings for each page. And we're going to compare them to the tokens of the query via a late interaction system. So what we're really doing is that comparing the image to the query directly. So as far as training is concerned, we trained Core-PaLi for industry-oriented use cases with lower adapters for the LLM weights and in-batch contrastive loss. So going a little bit further, yes, training details. So for the first version of Core-PaLi, we've collected 130, more or less, 1,000 pairs of query page for the training. We've trained that on one epoch for 8 AMD GPUs on Adastra, a supercomputer in France, for just 5 hours, and it cost only $300. So that was really interesting to have such a powerful model with a very low budget. Okay, so moving on to the results on the benchmark we've designed. So there's a lot of numbers. I'm not going to dive into all of them, but just for you to have an understanding of what happens is that you have all these different data sets as columns, all the different approaches that we've tested as rows, and Core-PaLi is there. And it's actually much better than standard contrastive VLMs like SIGLIP, notably on, well, more or less all data sets, but on academic data sets and also industrial ones. given that Shift is a dataset where it's very textual, so it's normal that standard constructive VLM is not very performant in that. Also, we've tried a standard approach where we've used ingestion framework like unstructured, plus captioning capabilities of very performant models. And we've used a BG-L3 approach for the retrieving. And this approach is actually, so Colpally is actually much, much better on the visual datasets. And we do not lose any performance on the textual datasets, something that we might have had if the vision capabilities were introducing some kind of bias. So on this Shift dataset, we are at the same performance as textual approaches, which is really good. Okay, so the main conclusion is that Colpally was a much better approach than all the standard pipelines that we had before. It's also very simple and fast, notably for indexing. Okay, I'm going to continue a little bit further. So yes, one point that's very important as well is that this late interaction mechanism allows us to compare each token of the query to the different regions of the image. So that's very interesting in terms of explainability to understand what parts of the document were matched to the query. So this is also a very good advantage of this approach. Okay, so I've talked a lot about retrieving, but the idea behind that is to perform visual RAG, end-to-end visual RAG, where we then feed the different images to a vision language model so that it answers to the queries of the user. So very standard.
Okay.
Okay, and there's several improvements that we can talk about. So we can have dynamic resolution with ColQuent2. So I've described the PalyJama approach before, but we've moved on to newer models. We can also have smaller models with the ColSmall family that was released by Hugging Face. And we can also improve the performance. So by tweaking the loss, increasing the training data sets, etc. A lot of things to do. Maybe I'll move a bit faster. Yes, something also very important is that we've designed a second version of the VidRay benchmark. It was a very good start, but it was actually relatively easy for the models. And in the V2, it's actually much harder, and the performances of the different RAG models, visual RAG models on this benchmark is much lower than before. So like we lose something like 30 points approximately. We are also in the process of constituting another benchmark, a V3, that would be even harder. Okay, so just to tell you, it's an open source project. So we've released everything for the first version of Colpally so far, like model checkpoints, the leaderboards, evaluation benchmarks, code bases, etc. It's an MIT license, and we're in the process of working on the second versions of Colpally. It's a very active research topic. We've had many contacts and partnerships with all these actors. And so if you're interested to discuss Colpally as well, feel free to get in touch. Thank you very much.
Thank you. Does anybody have any questions for Gauthier? No? No question? Oh, there's one.
Hi, would it be beneficial if we did some layout detection and detect tables and images, and then embedded those using Colpally, and that did drag on them? Would it be any benefit?
I think, I'm not sure, but I think that the models are sufficiently performant to understand the tables, figures in context in the page, and that we actually do not need to crop them before using them. I might be wrong, but my guess is that it's okay to use it like that. We could check, actually. Yes?
Thanks for the talk. Just a quick question. So, how do you handle that text breaks into parts when taking this different visual parts of the image? For instance, it's a PowerPoint presentation, and then there is some graphic, but also text, and then maybe one of the between two patches, there is a text is interrupted or something like this. How do you handle these cases?
Okay, yes. So within a single page, if you have breaks and a complex layout, most of the time it's able to understand it. On the other hand, if you have text that it's spanned on 2 pages, for instance, so if you miss context, so that's a problem. But for that, we're also thinking about learning contextual embeddings by, using the information of the previous and the next pages into the embedding of this page. So this is a very interesting problem.
So you're doing this already?
Yes, we're in the process of doing this. Yes. Thank you.
All right, thank you. Thank you, Gutierrez. Thank you very much. Okay, we have the last speaker for this session, but there's 5 more talks tomorrow at the same time here. The next one is Project Hami, and the speaker is Xiao Zhang. There you go.
Hello everyone, good afternoon. Okay, this topic is unlock the heterogeneous AI computing device, use unified management with Hami. Yeah. As the marketing group shows, the GPU shipment will 70% growing the 4 years. At the same time, the heterogeneous GPU will count to 20% as the market. But at the same time, the GPU, how to management with numerous number of GPU, the NVIDIA and the OpenAI and the other public cloud both of use the Kubernetes. Yeah, the NVIDIA use Kubernetes management the 100 million GPUs with Kubernetes. But at the same time, many challenges with Kubernetes. The first one, the Kubernetes scheduling GPU can only one GPU as the GPU sharing, and the second one, if we have many heterogeneous GPU, not only the NVIDIA but also the AMD, it's low beta solution with Kubernetes. So we open source a project named Hami. Hami is the heterogeneous AI device sharing meanwhile. So we want to improve the AI utilization and use the unified to management scheduling and observability to heterogeneous GPU. The Hami also can deployment in any public cloud with pluggable and the lightweight. Of course, we also support the seven vendors GPUs, not only the NVIDIA, but also the AMD, and the Google TPU, and the Huawei Ensemble, and the Cambrican. Okay. The most important feature is Hami supports the GPU sharing. We can imagine scenarios. We have a Chain 7B model. We want to deployment the A100, but the model can only use the 24G and not the entire GPUs. So Hami can sharing GPU to various different tasks with one MB GPU memory and the 1% the GPU core. Of course, we can have an isolation in the container. So if two tasks run the same GPU, we can isolation and the fault isolation. This is the Hami architecture. We use this assembly because they hijack operate the inside the container. So the application will through the Hami core and call to the CUDA. Yeah, these are the architecture, and at this time we can have the device memory isolation and the core utilization isolation and the failed isolation and transparent the GPU task with any refactory. So if we have native PyTorch or TensorFlow or the VRM task, we can just make this the before we. So this is the demo YAML. If we want to have two GPU and each GPU we just want the 10G and the 10% the GPU coring, we can use this YAML is okay. Just need to specify the three fields, how many the GPU we want, and each GPU we want to use the GPU memory, and each GPU core we want to use. After the task running, we can execute the NVIDIA SMI to watch the GPU resource allocation. We can see the two GPU with the 10G and in the container. Except the GPU sharing, we also support the rich, flexible, and the user-friendly the scheduling policies. The first of all, if we have two tasks in the same GPU, we can have different high priority. The task A have more high priority, and the task B has the slow priority. We also suppose at the same time we can, if we have different the NVIDIA series GPU in the AI cluster, such as the A series and the H and the Pasc and the Tesla is okay. We can schedule a different task with different series GPU. Also, we also support the GPU-based scheduling and the load scheduling. Imagine one scenarios. If we have many different important tasks, we want to schedule in different nodes with different GPU, so avoid the crash. But at the same time, if we have many small tasks, so we want to put this task in the same node, the same GPU to avoid the waste. So the Hami have different scheduling for handle the different scenarios. This is our fast-growing community. At the same time, we have 100 contributors and more than the 100 end users. Of course, we support the 7 heterogeneous AI GPU devices, not only the NVIDIA, the Huawei, Ascend, and the Cambrican. Of course, we also supporting the AMD and in other AI chips in China. Okay, if the users use Spark or they collocated the task in different ways, just like the Vocalo and the coordinator. The Vocalo is the self-incubating project, and the coordinator is open sourced by Alibaba. So the two open source projects also support the Hami to handle the GPU sharing and the heterogeneous GPU unified management, scheduling, and the observability also supported. This is our adopters. The many cloud vendors in China and around the world both use Hami to improve the GPU utilization and unified management of the heterogeneous GPU. Okay, this is our roadmap in the 2025. We will support the AMD and the Google TPU. So we also welcome the new contributors to join us, join the community. Okay, this is the way to join us, the GitHub and the Slack. So thank you.
Thank you, Xiaozhang. Does anybody have any questions for Xiaozhang?
So thanks. So first, thanks for the talk. Thanks for a very interesting talk. So I have a question. So I just want to verify that, for example, if I have a server, and in this server I have different Markov hardware. Can Harmony manage tasks in this server? For example, I just have one server. In this server, I have different Markov CPU, Markov GPU. Can Harmony manage this?
First, the server can run various hardware at the same time. 这个任务能够同时运行在不同的异构的 GPU 上面吗？可以的是吧？那就没有问题，那就可以管理。那我们可以精准调度到某一个 GPU 卡上去。如果这个任务能够同时运行在不同的 GPU 的话，就是可以的。那如果不能运行，我们把它调度上去，它会 crash。
Okay, thank you. Please feel free to drop by and ask more questions. Thank you. Thank you everyone for coming to these Spotlight Talks. That concludes it here. Also welcome you to check out the website spotlight.gosim.org to learn about the current Spotlight programs, the AI program, and there's actually a Rust Spotlight that'll be featured next week at the Rust Week conference in Utrecht. And then please learn about it, and then you can also nominate other projects yourself as well for the next GOSIM Spotlight, and also apply for your own projects as well. So hopefully we can see some of your future projects in the next GOSIM Spotlight. Thank you everyone. Thank you.